So, section 7.4, and we are up to page 499. So there's a couple things we're going to deal with today. We're not going to talk about properties of logarithms yet today. We're not going to be solving with logarithms. We're not going to be expanding and condensing, none of that kind of stuff. All we're going to talk about today is evaluating logarithms, and we're going to talk about graphing logarithms. And so in order to do those things, you have to understand what logarithms are. And so a generic logarithm would be something that looks, for example, like this. Log by equals x. The way you read this thing is log base b of y equals x. I should put that in words. That's the way you read this thing. Log base b of y equals x. Now there's a couple things I need to point out to you. And it's not me being a stickler, it's that if you don't write it correctly, it means something different. Notice when I wrote this, guys, if I draw a line, notice that the log and the thing I'm taking the logarithm of, the y, are on the same line. Where's the b? It's down below. Okay, it's been dropped down below. That's the number base that we're using to take the logarithm, and I'll explain what I mean by that in just a minute. Okay, it's important that you write this the correct way. What a lot of people do is they get a little sloppy, or they get a little lazy, or they don't really stop to think about what they're doing, and they write it like this. That says log of b to the y power equals x. If you don't write something down here as the base, by default it becomes base 10. We'll talk about our special logarithms in a little bit here. There are two special kinds of logarithms. One of them is log base 10, which allows you to not actually write the base in down there. So if you write it like this, you're actually saying that 10 raised to some power equals something, rather than b raised to some power equals something. It's a completely different statement. And so it's not about me being a stickler. It's not about me wanting things neat. If you don't write it with things in the right place, it means something completely different. Does everybody get that? So you can't be sloppy. Those of you that tend towards sloppiness in your writing have got to get over that, because it's going to get you into trouble. You've got to keep things on the proper line. Otherwise, they mean something different. This is related to something that we've been dealing with. This is related to our exponentials. Think about something like this. B to the x power equals y. That's an exponential equation, right? We've been graphing things like that, like y equals e to the x, or y equals 2 to the x, or y equals 5 to the x. So that's an exponential. It turns out, guys, that these things say the same thing. Log base b of y equals x says the same thing as b to the x power equals y. This is two different ways of writing what is essentially the same information. This is logarithmic form. This is exponential form. Now, they're not absolutely identical, because on y equals b to the x power, b can be anything. X can be anything, y can be anything. Now, to be an exponential function, b can't be anything. Technically, b has to be greater than 0. But x and y could be anything, essentially, although there is actually a little bit of a limitation on y. The idea that we have to concern ourselves with is, in logarithmic form, it's very important to understand that b and y must be greater than 0. The two numbers that are inside of the logarithm, the b and the y in this case, have to be greater than 0. They must be positive numbers. You are not allowed to have 0 inside a logarithm. You're not allowed to have a negative number inside a logarithm. Now, x, the answer, can be 0, it can be negative, it can be positive, it can be anything. But the stuff inside the logarithm, the base and what we call the argument, b is actually called the base, and y is called the argument. Those have to be positive numbers. So for example, you cannot have log base 2 of negative 5 equal something. That doesn't exist. You can't have log base negative 2 of 5. That doesn't exist. Okay, the base and the argument both have to be positive. Okay, so log base b of y equals x. The reason that this says the same thing, guys, is that we can take logarithms and we can unravel them. This is a technique that a student had actually shown me a number of years ago because they had another teacher that showed it to them. And when I showed it to the class really liked it. So I've been using it ever since. The way you change this from log form into exponential form is you start with the base. And then we're going to bounce back and forth from side to side. So I'm starting on the left. So I'm going to go to the other side, and I'm going to grab this number. That's going to be the power. So b to the x power, and then I'm going to come back to get my answer is equal to y. That's how you unravel a logarithm. The base raised to the answer as a power is equal to the argument, the number inside the logarithm. So let's look at this with actual numbers so it makes more sense. Log base 2 of 8 is equal to 3. Why? Because 2 raised to the third power is equal to 8. So do you guys see how these are related to each other? One's logarithmic form, the other one is exponential form. So one of the things they're going to ask you to do is take logarithmic form and change it into exponential. Rewrite it using an exponent. Or vice versa. Take exponential form and change it into logarithmic form. By instead of unraveling it, just re-ravel it. So let's do a couple more of those. And this is called evaluating a logarithm. So what if I gave you log base 3 of 81 and I asked you what is that equal to? Well, what you have to ask yourself is 3 raised to what power equals 81? So what's the question mark got to be? 4. 3 to the 4th power is 81. That means that this guy is really equal to 4. So log base 3 of 81 equals 4. Does everybody see how that works? Let's try another one. Log base 5 of 1/5 is equal to what number? So in other words, 5 raised to what power equals 1/5? Exactly. 5 to the negative first power equals 1/5. So that means that this logarithm is equal to -1. So again, the answer can be negative. It's just the stuff inside the logarithm that can't be 0 or negative. Does everybody see how that works? Whenever you get stuck working in one form, you want to try changing into the other form. If you're stuck in log form, unravel it. Make it an exponential. Likewise, if you're stuck in exponential form, you can re-ravel it into a logarithm, and usually that will show you what to do next. You'll be able to figure it out from there. So that's an important skill to remember. Okay, what if I gave you this? Log base 2 of x is equal to -3. What would x be here? Very good, 1/8. Why? Because 2 raised to the -3rd power equals x. And what is 2 to the -3rd power? Well, the negative power tells us we have to do what? Flip it, go down to the bottom. So 1/2 to the 3rd. And what is 1/2 to the 3rd? 1/8. So this then must be equal to 1/8. Does everyone see how that works? That's evaluating logarithms. What would this one be? What's log base 25 of 5 equal to? Nope, not 1/5. That would be 25 times 1/5 equals 5. We need 25 raised to what power equals 5? Nope. There it is. 1/2. Because the 1/2 power is really what? Square root. The square root of 25 is equal to 5. So this is really the 1/2 power. Do you guys see that? So be careful. Remember, that's a power. It's not being multiplied. It's being raised to that power. So now, do you guys see why this is called a base? Because it becomes that. And what's that called? Well, that's called the base. Right? The thing that's being raised to a power is called the base. So that base on that logarithm becomes the base on the exponential. So they have to have the same name. They're both called bases. Questions about any of that? So that's evaluating logarithms. Now, how would you change an exponential back into a logarithm? So for example, 2 to the 5th power equals 32. How do you change that back into a logarithm? Well, this would be log base what? What's going to go down here? 2. What's going to go here? What's going to go over here? Now, don't spend 10 minutes trying to figure this out. Just throw the numbers in where you think they should go, and then unravel it and see if it gets you back to what you started with. If I unravel this, what do I get? Is that what we started with? Yep. So we know that's right. But if you accidentally do this, when you unravel it, what do you get? What needs to switch places here to get this? You see how the 5 and the 32 have to switch places? So you know to make this 32 and to make this 5. And so do you see that if you don't do it right, as long as you check it, it's very easy to see what to switch places on? So don't spend 10 minutes trying to figure it out. Throw it together, check it. If it's not right, it'll tell you exactly what needs to switch places when you compare it to the original. All right, guys. Now, we need to talk about graphing. In order to graph, we're going to start with something like this. Let's graph y equals log base 2 of x. In order to graph, I'm going to use a t-chart. The problem is, guys, that there are some numbers that I'm allowed to plug in for x, and there are other numbers that I'm not. And I'm going to have to try and pick numbers that work out nicely, because if you guys look at your calculator, there is no base b, log base b button on your calculator. There are only 2 log buttons on your calculator. One is log, the other one is ln. We'll talk about those in just a minute. So let me show you the way that you graph these things. The way that you graph these things, guys, rather than plugging in for x and finding y, my recommendation is change this to exponential form. This makes life easier. So when I unravel this, what does this become? 2 equals what? X. So 2 to the y equals x. Then get x by itself. What do I have to do to get x by itself on this one? Nothing. It's already by itself, right? So now this is the one that we're going to graph. Do you guys see that this, I'm going to just rewrite it, x equals 2 to the y. Doesn't this look like the kind of equations you've been working with for the last week? The only difference is what? Yeah, the x and the y have switched places from what we're used to, right? Think back, guys. Remember inverse functions, where you switch the x's and the y's and then solve for y? Exponentials and logarithms are inverses of one another. So we unravel this, we make it into an exponential function, we get x by itself. Now notice that y is the exponent, so what we're going to do is instead of plugging our numbers in for x, we're going to plug our numbers in for y. There's no rule that says you have to plug in for x. It's just how we usually do it because usually y is by itself. Now x is by itself. So what value of y will make the exponent 0? So I'm going to use 0, 1, and 2, negative 1, negative 2. The only difference is I'm writing it on the y side because I'm going to plug them in for y. That's the one place you've got to be careful with this method. Don't accidentally write those on the x side. We're going to put them in for y. They need to be written on the y side. So now if I plug in a 2, what's 2 squared? 4. If I plug in a 1, what's 2 to the first? What's 2 to the 0? What's 2 to the negative 1? What's 2 to the negative 2? Can we graph that? Now, here's the only other thing, guys. Remember how when we did these as exponential functions, they had horizontal asymptotes? Y equals a number. What do you think we're going to have on this one? X equals a number, which means it's not going to be a horizontal asymptote. It's going to be what? Vertical asymptote. The rule, though, for how you do it is the same. What number is being added or subtracted out here? 0, so the asymptote is going to be x equals 0. So do you see that although these are different, they're inverses of each other, they work very much the same? X equals 0 is my asymptote. That's right here. So now we have vertical asymptotes instead of horizontal. Now I plug in my points. 4, 2, 2, 1, 1, 0, a half, negative 1, a quarter, negative 2. Do you guys see the shape of the graph? You see how it's getting closer and closer to its asymptote down here, and then it goes this way? There's the graph. Do you remember what the exponential graphs look like? Remember with inverse functions, guys, they are mirror images of each other across the y equals x line. Do you see it? So this is exactly what we would expect from inverse functions. Any questions about how I got the graph? So I unraveled the logarithm to change it into exponential, and then I did it just like I did the last 3 sections. The only difference is I plug in for y instead of plugging in for x. And I have a vertical asymptote, x equals, instead of a horizontal asymptote, y equals. So it's very, very similar, but it is slightly different. Question?
Asymptote x equals 0.
Because remember, this thing can never quite equal 0. So the asymptote, the line it gets closer and closer to without touching, is x equals, and then this thing would give us a 0. Remember, there's really a plus 0 out here. Remember, it's whatever's being added or subtracted that becomes the asymptote. But it's x equals now instead of y equals. Do you see it?
Yeah.
Okay, good question. All right, domain and range. Domain and range are going to be a little different now than they were on the other one. Remember, on the other ones, domain was always what? All real numbers, and range was always either bigger than or less than your asymptote. Now it's going to flip, guys. What is our range always going to be? All real numbers, because this thing goes down forever and up forever. So if I shine the light on it, do you guys see that it's going to cast light? It's going to cast a shadow all over the y-axis. But now the domain, look at the x's. What is x always bigger than or less than? Is it bigger than 0 or less than 0? X is always to the right, so it's going to be bigger than 0. If it went this way, it would be x less than 0. So do you see how they just change places, the x and the y? So therefore the domain and the range change places. So these are related to what we've been doing in the chapter, but they are inverses of each other. What used to happen with x now happens with y and vice versa. Questions on that? Now let me show you a couple of the trickier ones that you've got to be really careful of. What happens if we change this a little bit? What if they give us y equals log base 2 of x minus 1? Well, in order to unravel these, remember we're going to change this into exponential form first. In order to unravel these, you have to have the logarithm by itself. The log is all by itself because the negative 1 is inside the logarithm because of the parentheses. That's important to pay attention to. You'll see why. On the next example. So what does this give me when I unravel it? 2 to the y equals x minus 1, right? What do I do to get x by itself now? Add 1. So I have x equals 2 to the y. Does the plus 1 go here, or does the plus 1 go here? Outside, right? It's not part of the exponent, so it goes outside. This is what we're going to graph. Right away, guys, what is our vertical asymptote going to be now? X equals 1. So let's put that on our graph right away. Why 1? Because the 1 is being added at the end. So x equals 1. You guys with me? T-chart time. I'm going to plug in what as my middle value to make this 0. 0, 1, 2, negative 1, negative 2. There's only one problem, guys. What did I do wrong here? Put them on the wrong side. These are y's, not x's. So watch out for that. It's a common mistake. 2 squared is 4, plus 1 is 5. 2 plus 1 is 3. 1 plus 1 is 2. A half plus 1 is 1.5. A fourth plus 1 is 1.25. Again, use your calculator to help you out if you want. Nothing wrong with that. 5, comma 2. 3, comma 1. 2, comma 0. 1.5, negative 1. 1.25, negative 2. Everybody see the graph? There it is. What's our domain? X is greater than 1. We're always to the right of 1. What about our range? All real numbers. The range is always all real numbers on these, just like the domain was always all real numbers on the exponential ones.
Is it you have to go to 1.5 and 1.25 because there's a 1 on the other side?
Oh no, remember I didn't pick these numbers, I picked those numbers.
Oh, sorry.
Right? And then these are the numbers I got when I plugged those in. Because I would never think of plugging those numbers in, right? But these make sense. Does that ring a bell? Okay. Any other questions, guys? That was a good question. Because a lot of people will wonder that same thing. Now, to remind yourself to do this, guys, you can draw that little arrow at the y's just to remind yourself, oh, wait, I'm supposed to plug numbers in on that side because I unraveled the thing. Okay, so that's graphing logarithms. Now I want to show you the one that gets people messed up. This is not the one that gets people messed up. The next one is. Here we go. Y equals log base 2x minus 1. Isn't that the same as the one we just did? No, why not? There's no parentheses. So what is part of the, what are we taking the logarithm of here? X. We're only taking log base 2 of x. The minus 1 is not part of the logarithm. If I try and unravel this right now, I'm going to get 2 raised to the y equals x. The negative 1 is not part of the logarithm, so where would the negative 1 go then? It would disappear into thin air. Do you think that could possibly be right? No. You cannot unravel a logarithm until it's by itself on one side. So what we have to do is get this by itself by doing what? Add 1 first. Without the parentheses, we have to do this first. Now we have the logarithm by itself, so now 2 to the answer power equals what's inside. Now do you see where the 1 ends up? Different than the last one, right? So I'm going to rewrite this, x equals 2 to the y plus 1. This is what we're graphing. What's our vertical asymptote? X equals 0, so let's put that on the graph right away. What should we plug in as our center value for y? What makes this 0? Negative 1. Good. I would use negative 2, negative 3, 0, and 1. When I plug in negative 3, I get 2 to the negative second, which is 1/4. Here I get 2 to the negative 1, which is a half. Here I get 2 to the 0 is 1, 2 to the first, 2 to the second. So 1/4 comma negative 3. A half comma negative 2, 1 negative 1, 2 0, 4 1. Do you guys see the picture? What's our domain here? X is greater than 0. What's our range? There you go. That's it. Now, does everybody see how these work? Do you see how similar it is to exponentials, but that it is very different at the same time? Don't get the two confused. If you're unraveling a logarithm, that's when everything flip-flops. You do everything with y instead of x. I shouldn't say everything with y. You plug in for y instead of x, but your asymptote becomes vertical instead of horizontal, so it's x equals. All right. So no questions? I'll give you guys the homework assignment. Any questions?